Hello to my fellow friends and lecturer Mr. Amiru. Today we are going to do a presentation slide about experimental on shear force. There are 10 members in our group. The group members are me, Senn Hing, Jia Jian, Lim Fang Yao, Lim Foo Keong, Dee Shen, Tien Hou Yu, Lim Wei Liang, Jang Hern, Tung Yu Heng, and Ji Hong. First is the introduction.
Hi everyone, my name is Lim Fang Yao. Today I want to talk about the shear force in the beam for the experiment. The first is what is the shear force? The shear force is the force acting perpendicular to its longitudinal axis. Next is the word shear in the term is a reference to the fact that such a force can cut or shear through the surface or object under strain. Okay, the next is what we can do the experiment by using the shear force. First, we have to set up the perform shear force in a beam experiment in this experiment. Another that is the shear force or shearing forces can be defined as a force that which is responsible for shearing action of a beam. Okay, thank you.
Objective. By bringing out this experiment, we can understand about the action of shear in a beam, and also we need to find out how the shear force varies with an increasing point load, and also how shear force varies at the cut position of the beam for various loading conditions.
Force is the force operating on a sustain in a direction proportional to the sustain extension and parallel to a body planar cross-section. While another portion of the surface is being pushed in the opposite direction, one portion of the surface is being pushed in one direction. They are called compression force.
Procedure 1. We need to arrange the prepared things. 2. Measure internal total displacement and total length. 3. Apply weighted steel on steel ruler. 4. Measure total displacement after load applied. 5. Use the formula to calculate angular displacement. 6. Repeat step 2 to step 5 with other weight such as 200 gram, 300 gram, 400 gram, and 500 gram. 7. Record the result in table and put out the graph.
Hello, my name is Tien Hou Yu. I'll continue the presentation slide, which is result. Now we look at the slide. There's a wave with grams. It is 0 to 500 grams. The total length are all the same. There is no changes. It is 8.0, and then the total displacement does change. Like 100, as you can see, 100 is 1.8, 200 is 3.7, 300 is 5.5, 400 is 7.3, 500 is 9.4. And then the angular displacement, for 100 grams, it is 12.68, and 200 is for 24.82, and then 300 is for 34.51, and then for 400 is for 42.38, and then 500 is for 49.60. And then the next slide is there's a mass, load, experimental shear force, theoretical shear force, and error. And then the mass is same, which is 0 to 500. And then the load at 100 grams is 0.98, and then 200 is 1.96, and then 300 is 2.94, and then 400 is 3.92, and then 500 grams is 4.990. And then the experimental with the 100 grams is 0.6, and then 200 is 1.1, and then 300 is 1.8, and then 400 is 2.3, and then 500 is 2.7. Now we move to the theoretical. The theoretical for 100 grams is 0.58, and the 200 grams is 1.16, and then 300 is 1.74, and then 400 is 2.32, and then the 500 kilograms, the 500 grams is 2.9.
Hey guys, my name is Jia Jian and my student ID is DSIC DAET 0722056, and this is how we bring out the calculation. So the angular displacement is the tangent power -1 times total displacement divided by total length. For the 100 gram, the angular displacement is 12.68 cm, and next 200 gram is 24.82 cm, and following is 300 gram is 34.51 cm, and then 400 gram is 42.38 cm, and next 500 gram is 49.60 cm. And next is the calculation for errors. We use the experimental shear force minus theoretical shear force, then divided by theoretical shear force, then times by 100%. Then the first 100 gram is 3.45%, and then 200 gram is 5.17%, and then 300 gram is 3.45%, and then 400 gram is 0.86%, and then 500 gram is 6.9%.
The first graph shows us angular displacement and the weight. As you can see, the longer distance of displacement, the weight will become more heavier. And the second is about load and experimental shear force. The bigger amount of the load will increase the shear force. And the third graph is load and theoretical shear force. It is basically same as the second graph, so the bigger amount of load will also increase the shear force.
My name is Lim Wei Liang from DAET KC1. My student ID is DSIC DAET 0722048. Now is my part discussion. For question number 1, given the new value for total displacement is 18 cm, find the new angular displacement. Angular displacement is equal to tangent power -1 times by 80 cm divided by x cm and equal to 66.04 cm. And now question 2, what is the application of the shearing or tangential stress in automotive system? Shearing stress is a kind of stress which acts coplanar with cross-section of material. It takes place because of shear force. They are the pair of force which act on opposite sides of a body with the same magnitude and opposite direction. In figure 1, show the drive shaft of a normal rear-wheel drive car, which mostly transmits torsion when power is transferred from the transmission to the differential joint, where the rotation is directed to the drive wheel. These shafts, which are usually hollow and circular in cross-section, parallel to pressure vessel, it is important to comprehend the design technique for this type of structure simply because of their nature value. When a shaft is subjected to a torque or twisting, a shearing stress is produced in the shaft. The shear stress varies from 0 in the axis to a maximum at the outside surface of the shaft.
So finally, we are going to talk about conclusion. So from this experiment, we can conclude that we were able to determine how shear force varies with an increasing point load. Besides that, we also know what is the meaning of shear force. Next, we can conclude that if more load is placed on the beam, the shear force will also increase. And finally, it was proved that shear force at the cut section is up to the forces acting both right and left side of the cut section on the beam from this lab experiment.